4, we asked the questions, what angle had a sine of root 3 over 2? So when we saw that root 3 over 2, which triangle were you working with, 30-60 or 45s? We were working with a 30-60. So when you worked with the 30-60, you had a 1, root 3, and a 2. Which one of those angles gave you the root 3 over 2? Guys, worry about it later. Let's do this. For sine, which one gave you root 3 over 2? The 60-degree angle. The 60-degree angle gave you the root 3 over 2. Now, the 60-degree angle, we never used the degrees, though. We did it in terms of radians. What was the 60 in radians? Very good. So this was at pi over 3. Now, think about also, when you dealt with sines, cosines, tangents, if they were positive values, they were positive in more than one quadrant. What two quadrants is sine positive in? Do you remember? First and second. Now, what you did right here was you found the reference angle within the first quadrant. You guys did really well at this stuff. So this isn't anything new. It's using this what you did a while ago. So if you had pi over 3 in the first quadrant here, in the second quadrant, what would the other angle be that shared the same sine value?
120.
Remember, if this is 0 and this is pi, coming up pi over 3 means that this is at 2 pi over 3. Okay? Because it's pi over 3 away from the axis when you found your reference angles. So the two angles that had the sine of root 3 over 2 was pi over 3 and 2 pi over 3. Or if you want to say 120, it's 60. They both work. Same idea with tangent. Tangent was what over what? Sine over cosine. If you wound up with the sine over cosine and it wound up equaling 1 or negative 1, which triangle were you in? You're in the 45s, very good. So when you're looking at a tangent with the 1 and 1, you're obviously at a 45, which means, what was the radian measure for 45s? Pi over 4. Now, for it to be a negative value, what quadrants were tangent negative? Second and the fourth quadrant. So that meant that my reference angle was a pi over 4 coming up in the third quadrant. So what was that in radians? If I'm coming up off the axis pi over 4, what is my angle over that? 3 pi over 4. Very good. And then down here, all you had to do to get the other angle was just add pi to it. So you get 7 pi over 4. We've done these problems. What's going to be different today is that it's going to start by looking like this. Solve an equation. You're going to solve the equation, and we're going to talk about what are called general solutions. There's going to be two types of solutions that we're going to look at. We're going to look at general solutions, or we're going to look at it in terms of one revolution. Thanks, Mark. So if I'm looking at this equation, I have 2 times the sine of x minus 1 is 0. I have to solve for x. Again, this is going to be nothing more. In this case, it's going to be 1, 2, 3 steps to get x by itself. What do you think the first thing you have to do is? Add 1. Good. So you add 1. You get 2 sine of x is 1. Now what do? Divide by 2. Not 2 sine, just divide by 2. Correct. And Mommer just said, how do you undo sine? Inverse sine. We're going to use inverse sine in here. So x is going to equal the inverse of sine of 1/2. Again, it's a 30, 60, 90 triangle because you have a 1/2. We all know that when you set that up, we're looking at our triangle. So it's 1, root 3, and 2. It's the 30-degree angle. It gives me a 1/2. Now, in terms of radians again, do you guys remember what the 30-degree angle was? Very good. So so this x value is going to be at pi over 6. And what's the other one then? Remember, sine is positive in the first and the second quadrant. Very good. over here is 5 pi over 6. Now, let me explain to you what the, yes, sir?
Maybe, I thought you said something.
First and second. The second and the fourth was tangent. Now, this idea of a general solution. If you think about your unit circle, let me go back one spot here. You think about our unit circle. We found that the sine of pi over 6 was at 1/2. If I go around the circle, don't I hit it again after 2 pi? If I go around again, don't I hit it again after 2 pi? If I go around again, don't I hit it again at after 2 pi? So every multiple of, if I add 2 pi to it, I'm always going to get 1/2 of the sine value for that answer. So what's happening here is that's what you would call a general solution. Every time you get to pi over 6, move this up a little bit. Every time I get to pi over 6 plus 2 pi, however many revolutions, we use n for that, n times. So if I'm at pi over 6, if I go around the circle, 2 pi, I'm there again. Go around the circle, I'm there again. Infinitely many times. If I go around 12 times, my angle will still have that reference angle of pi over 6, therefore it's still going to have a sine value of 1/2. A general solution is nothing more than how much pi does it take to get back to the same thing. Usually with sines and cosines, you're adding 2 pi. Sometimes with tangents, you're adding pi. Sometimes with tangents, you're eating pi too. Sometimes with tangents, you might have a pi over 4. And we'll get to more of that over the next day or so. Okay? N for a number of times. Same idea with the 5 pi over 6. If you think about when sine is, we're looking for just a positive value of 1/2. Sine is only positive in the first or the second quadrant. So that means in order for me to get back to that second quadrant, I have to add 2 pi to it to get back to the same spot. And I continually go around and around and around. So the general solution is basically nothing more than how long does it take you to get around to that same spot again? Does that make sense? I don't think we really discussed that when we were solving just the simple ones before, but that's what it looks like when we start talking about the equations. Yes, ma'am?
Can you do -2 pi?
You can, but they're always positive people. We're positive people. Yes, sir.
Does that mean in reality it would be like pi over 6 plus minus 2 pi n?
Yeah, you can think of that.
It would go both ways?
Yeah, you can think that. But we always go positive, though. We just continuously go from positive.
So we like try to ignore the idea that you have like a negative easy measure?
Yeah, don't have to worry about it, because when we're dealing with a negative value, can't we find the sign of a negative 1/2? That just needs to go to the different quadrants. That's all it is. So the positive 1/2 is just in those 2 quadrants we're adding to go back around. I see what you're saying, like you can subtract and go back in that way as well, but we're always just going to deal with it just a positive revolution. Okay? Yeah.
The x value is negative, and once we give the sign value.
Yes, and I have examples of that in here. It's exactly right. Just like we did with that 13.4, if you found the negative value, you're looking at different quadrants. We do the exact same thing here. Okay? Take a look at this one. I have 4 times cosine of x plus 1 equals negative 1. And I think this is the example we think of very well. So if I do this, what's the first thing you're going to move? So what's negative 1 minus 1? Good. So I have 4 cosine of x equals negative 2. Now what do you do? Divide by 4. So we have cosine of x equals negative 1/2. Is everybody okay with that? Just simplifying it right off the bat. And then lastly, we take the inverse of cosine. So what value of cosine has an, or what angle has a cosine that is negative 1/2? So you're looking at it, you're already a step ahead of me about the 60 degree. Okay. So we know that it's going to be at 60 degrees when we draw our triangle. So I know, or wait a second here. If it's 60, wouldn't that be root 3 over 2?
It's cosine.
Didn't you write that?
It's not. Oh, yeah.
Oh,
yeah.
yeah.
It's cosine.
Yes.
Oh, excuse me.
Sorry, didn't mean to scare you like that. I never make mistakes. All right. So yes, 60 degrees gives you the 1/2. Now, what quadrant is cosine negative?
Um, third and fourth.
Cosine is negative in the second and the third. Second and third quadrant. So that gives me a reference angle here of pi over 3. Everybody agree with that? 60 degrees to 2 pi over 3 is pi over 3. So that means this angle in the second quadrant is 2 pi over 3. And what's the angle down here then? Very good. So we add pi. Wait a second. If this is 3 pi over 3, if I add a pi over 3, wouldn't that be 4 pi over 3? So my two angles then, because the reference angle is at pi over 3. So you move it above and you move it below. Yes, sir?
Yeah, but the denominator is 3, so 3/3 is 1.
Right, so you add a pi.
You added 2 to 2. You need to add 3, right?
From here, yes, it's 3 pi over 3. To move it up, because it's pi over 3, I subtracted 1. And to move it down, I added 1.
Oh, adding 1/3. I think you wanted to add more pi.
No.
I was confused.
You were thinking about switching to the fourth quadrant.
Fair enough.
Okay. So now, again, these two solutions, in the second quadrant, 2 pi over 3 is only going to occur if you add 2 pi to it. The one in the third quadrant is only going to occur when you add 2 pi to it as well. So your general solution, you tag it on 2 pi n.
Now, would we use like and, or would we use
Comma. There's two.
or? Comma?
Yep. Yep. You just say and those things. So what I want you guys to work on here with these tonight, we're not going to get too crazy involved with a lot of the weirdness yet. I'm going to give you, I think, about 4 of these to look at. What I'd like you to do is not worry yet so much about the general part. I'd like you to solve. If you want to try and do the general to check it for tomorrow, go for it. We're going to do generals again tomorrow, as well as one revolution stuff. Where did I write them down? I wrote them down back here. You're going to find that the equation ones that I'm going to give you tonight are going to be relatively straightforward. There should be no scariness involved at all. It's on 859. I'd like you to try numbers 19, 20, 22, and 23. Okay? I want you to try those 4. It does say to write out in terms of general solution, but if, obviously we did this for about 10, 12 minutes, if you're not quite sure on your general solution, you can still solve it without a problem. Yeah?
What is it? The general solution is what you got plus 2 pi.
It depends on which angle you're looking at. Because if you're dealing with tangent, sometimes tangent's positive one here and here, so then you'd just be adding pi each time. Yeah, you could be adding pi. Sometimes you can get, if it's a square root, you can get plus minus. So you can be getting all things in all 4 quadrants. So you can be adding pi over 2 to answers. It really depends on the problem itself. So let's just start with just figure out what it is within a revolution, and we'll talk more about the general tomorrow. Okay?
How much are we
Yeah, we'll get the square roots. We're gonna, this, you have to be factoring with this as well eventually also. Okay? We'll also be, there will be parts of this stuff that you will have to use a calculator. I don't know if we're going to get to that tomorrow, but it might not be a bad idea to have your, because I know we haven't had to use a calculator in a while. Make sure you bring them tomorrow just in case we do get to the calculator portion of this. So again, you'll see that there'll be calculator, non-calculator. Just kind of A little heads up.